We can think about a solution forming in 3 steps. The first step would be separating the solute into particles. So whatever the solute is, it was together, right? And then we're going to have to separate it into individual particles. That's always going to be endothermic. We're going to have to put energy into it because it was a substance, perhaps it was a liquid or a solid, because the intermolecular forces were holding those particles together. To separate them, we're going to have to overcome the intermolecular forces. So delta H for the solute is greater than 0. We also need to separate the solvent particles to make room for the solute. That's another endothermic process. So delta H for the solvent is greater than 0. And then we're going to mix the solute and solvent particles. That's going to be an exothermic process because energy is going to be released when the particles interact with each other. So you're going to have the solvent molecules and the solute molecules. There's going to be some type of attraction between them. It may not be enough to overcome those first 2 problems where we need to put energy in, but there will be some exothermic process here when they're mixing. So delta H for the mixing is less than 0. Remember, delta H being negative is good. That's going to want to happen. We want to lower delta H, more negative. So when we talk about the enthalpy of solution, it's the sum of the changes in enthalpy for each of these steps. Enthalpy of solution is the heat involved in making the solution. So the overall sign is going to depend on the magnitudes of the individual terms. The first 2 are going to be positive, the third one's negative. And whether the overall enthalpy for the solution formation is positive or negative depends on which ones are bigger. So solution formation can be exothermic or endothermic. So here's another one of those crazy looking diagrams. So here we're starting right here. We have the solvent aggregated, meaning it's together, and the solute is aggregated together. So these are both together. That's not a good way to say it. They're the solvent's all together, the solute's all together, but they're not mixed. So the first process is taking the solute and separating it. And that's going to be a positive delta H. So we have to put energy into it. We also have to separate the solvent molecules so that there's room, and that's going to be positive. We're going to have to increase the energy. And then when we get these guys all separated, when we mix them, we're going to have a release of energy. If this release of energy is greater than the sum of these, then we have a net exothermic process. Here's a different solute. Again, we're separating the solute into particles. We're separating the solvent into particles. And then when they mix, this time the energy that's released is not as much. It's less than the sum of these 2. And so we have a net endothermic process for the mixing. Any questions? So when we make aqueous solutions of ionic compounds, we can talk about a heat of hydration. And that's delta H for the solvent and delta H for the mixing. So this was the amount of energy needed to separate the solvent molecules, and mixing was the amount of energy released when the mixing occurs. So that enthalpy change, the enthalpy change that occurs when 1 mole of gaseous solute ions is dissolved in water. That's what heat of hydration is. Since we're talking about a mole of gaseous ions, there's no separating of the ions there. They're already separated. They're in the gas state. And so when you mix them, you've got the solvent molecules, the water, coming apart to make room for the ions, and then you have the release of energy from the interactions between the ions and the water molecules. What kind of interactions were those? It's the fourth intermolecular force, the strongest one. Ion dipole forces. So the heat of hydration is always going to be exothermic, and it's going to be large. Always largely negative. That sounds like, well, it's always mostly negative. No, it's always big and negative. Always takes me a minute to look at this, make sense of it. So the energy required to separate the solute molecules is going to be the negative of the lattice energy. Remember when we talked about lattice energy? Lattice energy was when you took ions in the gas state and you put them together and it released energy, right? So if we're going to do the opposite, if we're going to separate those ions from the solid into the gas state as separate ions, it's the same amount of energy, just with a different sign. So we actually, we can measure that lattice energy, so then we can know what this heat of solute is, the energy needed to separate the solute particles. So the heat of solution, the enthalpy of solution, was the energy to separate the solute molecules plus the energy to separate the solvent molecules plus the energy of mixing. I'm getting some interesting looks. Remember we did this? So we are separating the solute, we're separating the solvent, and then we're mixing them. Okay? So that's what this guy right here is saying. You add those three things and you get the energy of the solution. We are defining the sum of these two things as the heat of hydration. The heat of hydration is going to be negative. The heat of the solute here, separating the solute, is lattice energy positive or negative? Is energy released when ions come together? Yes, it is. So if the lattice energy was negative and delta H for the solute, the energy to separate the solute particles is equal to the lattice energy with the sign changed, then this has to be positive, right? So this is going to be a positive number. This is going to be a negative number. So here we've got potassium fluoride as a solid. So we have to separate the particles into the ions in the gas state. The energy needed there is the lattice energy, but opposite in sign, because it's the opposite process of the lattice energy. The lattice energy is these ions in the gas state, and we're letting them come together. It releases a whole bunch of energy. So the energy there is 821 kilojoules per mole. And then we've got them in their gas state, they're separated, and then the energy of hydration is how much energy is released when they mix with the water. And so for this one, it's minus 819 kilojoules per mole. And that's close to this one, but not the same. And so the heat of this solution is plus 2 kilojoules per mole. It requires 2 kilojoules per mole of energy to put in to form this solution. Where does it get that energy? Is there energy in the air around it? Is there any heat energy? Yeah. So what this solution does is it pulls energy in from the surrounding, thermal energy, and what we observe is that the solution gets cold. energy goes into it, where does it go? It goes into those interactions, and it causes the energy of the solution to, the kinetic energy of its solution, the thermal energy, to go down. So when we have that heat of solute being larger than the heat of hydration, like we do here, we have an endothermic process. Energy goes in, and the solution feels cool because the energy is coming from the surroundings. If this one is smaller than that one, if this one is larger, this one. If this one is larger than that one, then we have an exothermic process. And where does the extra energy go? It goes into the surroundings, and it feels warm. Any questions? That was like a really horrendous explanation of that. I'm watching him think. Do you have a question?
Back in the other page, is it the same process? Yeah. If the summation of the solution and solute was greater than the mix,
Mm-hmm.
it was a net endothermic?
This is endothermic because more energy goes in than comes out. And on this one, this one right here is also endothermic because more energy goes in than comes out. It's one of those things that you just kind of have to wrestle around with in your brain until you see it. Sometimes I have to stand here and look at these slides and I'm like, what on earth is that? It's a great picture, but sometimes we're not sure what we're looking at. Anybody else have a question?